This is Chapter 5.3, Graphing Quadratics in Vertex Form, and this is question number 15 on page 272. So, a video tracking device recorded the height, h, in meters of a baseball after it was hit. The data collected can be modeled by the relation h equals -5 t minus 2 squared plus 21. So this is in vertex form, this equation, where t is the time in seconds after the ball was hit. So A asks us, sketch a graph that represents the height of the baseball. So what I like to do first in questions like this is find the vertex. So that will be the first point that I like to plot. So on this graph here, the y value is the meters, the height, sorry. So height, which is measured in meters, and then the x value, the x-axis, is the time, and that's measured in seconds. Okay, so I like to find the vertex first. So we can do that by finding h and k in our vertex form equation. So h minus 2 equals 0, and so h is equal to, bringing that 2 to the other side, so it changes signs, h is equal to 2. And then k is an easy one because it's always the same, so k is equal to 21. So now we have our first point on the graph, so 2 and 21. So you can plot that right now. So after 2 seconds, the ball is 21 meters high in the air. So that is our first point on the parabola. So I'm just going to go and plot that right here in our table because it's a nice way to organize things. Okay, so now to find out the rest of the parabola, you can use the equation to find out the other points. So h equals -5 t minus 2 squared plus 21. So if we want to find either side of this 2 over here, I'm going to use the points 0, 1, 2, 3, and 4. So that's going to be these points right over here. So all we need to do is plug it into the equation. I'm only going to do 1 or 2 of these because I don't want the video to take up too much time. So let's start with 0. So what you would do is just plug the x value into t, because in this scenario x is t. So h is equal to -5, 0 minus 2 plus 2 squared plus 21. So 0 minus 2 is just 2. So h equals -2, sorry, 5, -2 to the power of 2 plus 21. So, oops. Now let's keep on going. H is equal to -5, and that's 4. -2 to the power of 2 is 4 plus 21, and then h is equal to -5 plus -5 times 4 is -20 plus 21, and that means h is equal to 1. Okay, so then you just plug that in right over there. And then I don't have enough room here to show you everything, but what you would do is just plug in these numbers in the t value. So, okay, sorry about that. So the x is equal, so if you plug these x values into the t and just solve, you'll get the y value. So this ends up being, when x is equal to 1, y is equal to 16. When x is equal to 3, y is equal to 16. And when x is equal to 4, y is equal to 1. And so now we can plot this. So 0 and 1, 1 and 16. We already plotted that one. 3 and 16. And then 4 and 1. Okay, sorry about that. My brother is not listening to me right now. And sorry, I should have plotted this one a bit higher. But anyway, so now we have successfully graphed our relation. So this is y equals -5 t minus 2 squared plus 21. And now I'm just going to do the last few questions. These are really simple. So B asks, what was the maximum height reached by the ball? And if we want to find the maximum height, all we have to do is look at the vertex. So this point right over here. So 2 and 21. So if we want to find the maximum height, we have to look at the y value, and we can see that it's 21. So the maximum height is 21 meters. And when did the ball reach its maximum height? All we have to do is look at the time or the vertex and look at the x value, and we can see that at 2 seconds the ball reached its maximum height. So 2 seconds. And then approximately when did the ball hit the ground? So since this is where the ball was hit from, at 0 seconds, you can see at around like 4.1 seconds, maybe, approximately. At 4.1 seconds. So there you go. This was, once again, question number 15 on page 272.